Alright, in this video we're going to discuss transformations of quadratic functions, and later on you will understand fully when we say what does it mean when we say transformations of quadratic functions. But basically when we say transformations of quadratic functions, we try to create another graph from an existing graph, or try to using their relationship. Okay, so we're trying to get the equation of another function from another function using a certain relationship, using a certain concept. Okay, using a certain concept of the standard form of quadratic functions. Okay, so but before that we'll do some review so that we can establish the concepts throughout. Okay, so this is the standard form of quadratic function. We have y equals a quantity x minus h quantity square plus k. So in this video we're going to discuss what happens when we change the values of a, when we vary the values of a. Okay, that's what we call vertical scale. Okay, vertical scaling. Okay, then what happens when we vary the values of h. Okay, that's what we call horizontal shift. And what happens when we vary the values of k? What is the effect of that to the graph? Okay, so that's vertical shift. So that's the idea there of when you say transformations of quadratic functions. So when we try to change the values of a, h, and k, there is another graph that is being formed. So that's what we call transform. Okay, so from an existing graph. Okay, so from an existing graph we change either a, h, and k, or simultaneously h and k. There is another graph that is being formed. So that's what we call transformation of quadratic function. So we know that in our previous discussion that the hk, the point hk is actually the turning point of the graph, or the vertex of the parabola. Okay, or the vertex of the parabola. We say if a is negative, or if a is less than 0, that hk is a maximum point. If a is positive, or if a is greater than 0, that hk, that point hk is the minimum point. Okay, or the turning point. So here we have described each this one in terms of the value of a, h, and k. So we have number one, we have, it's all number one, but let's just change it to number two and number three. So number one, we have y equals 2 times quantity x minus 2 quantity square minus 3. So the value of a is 2. Then it tells us that this graph opens upward. So the graph looks like that. Then we have the vertex of our h is 2, and our k is, no, our vertex, our h is 2, our k is negative 3. So we have a vertex of 2 and negative 3. So that's it. The graph opens upward, and the turning point here, this one, is 2, negative 3. Okay, in number 2, it's not quite like this, but we can write it into like that. We can rewrite this as y equals x minus 0 square. So it's the same idea, it's just the writing, just to make sure that we can rewrite it into this one. Okay. So here a is 1. It still opens upward. Okay, the direction of the graph opens upward, and the vertex, it's at 0 and negative 7. So imagine the vertex of the parabola, it opens upward, and the vertex is at 0, negative 7. So it's below the x-axis. Okay, then going up. Okay, so that's it. Number 3, so this one is just kind of review. Number 3, we have y equals negative x squared. To view it as like this one, we can write it as negative x, sorry, Can erase that. Negative x minus 0 square, let us say plus 0. So it tells us that the graph opens downward. Okay, the graph opens downward. Then the vertex is at 0, 0 at the origin. So it's like this. So the vertex is there and it opens downward. Okay, so just a hint again, if that is positive x squared, the graph opens upward. So again, as discussed before, negative x squared is just a reflection of positive x squared along the x-axis. So the x-axis is their axis of reflection. Okay, the axis of reflection. So we have here, let's start with the effect of the value of a. So we have here this one, the black, is the y equals x squared. So this discussion, our reference function and our reference graph is y equals x squared, meaning we are going to transform other functions based on x squared. Okay, so we have here the first one is this one, the red one, is that is y sub 1. Let us say that's y sub 1 equals, or y sub 2 equals 2x squared. Then the green one, that is y sub 3 equals 5x squared. 5x squared. And the purple one, that is y equals 10x squared. Y sub 4, that is 10x squared. So what I am trying to emphasize here, that as you can see, when from x squared, look at the graph, it's very wide. When you tend to make a larger, from 1 it becomes 2. Okay, so from 1 it becomes 2. From 1 it becomes 2 here, then it becomes 5, which is the graph, the green, then it becomes 10, which is the purple one. So when the value of a gets larger, actually not just the value of a, but the absolute value of a, the positive value of a. Okay, the absolute value of a, when the absolute value of a gets larger and larger, the graph gets narrower and narrower. So it's being stretched out. Stretch. That's what we call, this one is the idea of vertical scaling, but we're going to get further that later on. So let's try with a specific one. So this one is x squared and 5x squared. No. Yes, this one is y equals x squared, and this one is y equals 5x squared. So the effect of value of a, it's that every y value on the graph of x squared. So look at this. The idea is this one, it's like, to get this, it's just being multiplied by 5. Okay, so x squared is just being multiplied by 5, meaning this one is being multiplied by 5 to obtain y equals 5x squared. So that's what we call vertically scaled. Okay, by some factor. Okay, by a factor, on this case by a factor of 5. Okay, meaning, what does it mean? If you're going to consider this is 1, actually that's 1, okay, there, and this is 4, that's actually 4. If you're going to multiply this by 5, you'll get that 5, because 1 times 5 is 5, 1 times 5 is 5, and 4 times 5, that's 20, which is this one. So from this to this one, that is 4 times 5. Okay, so the 4 Okay, this 4 is the coordinates of x square. Okay, so it's the same here. Okay, so it's still 4 times 5, so it becomes 20 there. Okay, so every y value on the point, on the coordinates along in the x square is being multiplied by 5. So meaning by using the x square, just multiply all the y coordinates of each points, you'll get y equals 5x squared. So I think from this equation itself, it's very understandable and logical that yeah, x squared is just being multiplied by 5. So meaning other points, you can get this graph by just multiplying. You can get the green graph by just multiplying the y values of the black graph. Okay? So meaning from here in this 4, the value there is 16. Okay, this is 16. So the green graph is actually what we call the transform graph or transform function. Okay, so our original graph is the x square and the transform graph is the 5x square. So transform because by just multiplying x square, we'll get 5x square. 5x square now is our y equals 5x square now. Let's say y sub 2. Y sub 2 equals 5x square now is our transform function or transform graph. So imagine this is 16 in the x square. Since the y value is 16, 416. Okay, so this is 416. That's 416. Okay, so if we're going to locate that point on the green graph on the y equals 5x squared, we'll just simply multiply the 16 by 5. So 16 times 5. So if we're going to continue there, upper portion on that graph, that will become on the green graph, we'll have 16 times 5 is 80. So 480. Okay, so meaning the main idea is by using vertical scaling, okay, or the effect of A, okay, we can sketch the graph of 5x squared with reference to x squared. Okay, with reference to x squared. So in this idea, we say if we're going to compare y equals x squared is vertically scaled by a factor, or it is being multiplied by a factor of 5 to obtain y equals 5x squared. Okay, so remember, the x value is not the one being multiplied by 5. It's the y value along y equals x squared that is being multiplied by 5. Okay, so here we have compared the graph of the transformed functions g of x equals 9x squared and h of x equals 20x squared with the graph of f of x equals x squared. Okay, so we have here the same, so x squared. Here we have x squared and 5x squared. Here we are trying to compare 9x squared with respect to x squared. So let's try comparing g of x, okay, and f of x. Okay, so since we have the name, so we can say g of x. No. Can erase that one. Erase first. So f of x. No, that's correct. G of x. No, that's number 1. So for g of x and f of x. Okay, f of x is being is vertically scaled by a factor of 9, by factor of 9, to obtain um, g of x. Okay, so what does it mean? That we're going to multiply the y value of the coordinates on the points of x square, will get g of x by 9. We'll multiply that by 9. Okay, so for h of x and f of x, so it's like saying that the f of x is just vertically scaled by a factor of 20 to obtain h of x. Okay, so it's the same idea. Okay. So here we have given that 2, 4, the point 2, 4. Okay, so let's erase this first. So let us say that 2, 4, of course it's in f of x. It lies in f of x because when x is 2, f of x is 4. So again, let's recall that do not be confused with f of x. That's just simply saying that is just y, because we say y equals f of x. I think that's in previous year, grade 8. So let us say given that 2, 4 lies on f of x, meaning 2, 4, we can locate the point 2, 4 on the graph of x square. Okay, we can locate the point 2, 4 on the graph of x square. We're going to transform that point. It's like transforming that point. Okay, let's find this corresponding point when it is being transformed in g of x and h of x. Okay, remember, it's only the y value that is being multiplied. So from f of x to g of x, okay, remember this is 2, 4, and we have 9x squared. So let's just simply multiply 4 by 9. So we will get, in g of x, that 2, 4 becomes 2. 4 times 9 is 36. Okay? So from 2, 4, it is vertically scaled up to 2 and 36. So imagine that one. So if you have here 2, 4, it is being vertically scaled up to 236. So this is f of x. This is g of x. Okay. So for f of x, from f of x to h of x, okay, and in f of x, there lies there the 2, 4. Of course, we'll just simply multiply 4 by 20. So 20 times 4, that is 80. So meaning in 2, 4, that the point 2, 4, when it's being transformed, it becomes 280 in h of x. Okay, because the 4, the y value there is being multiplied by 20. No, it's this one. Okay, so that's it. So here we have a greater than 0 and a less than 0. We call this reflection. Okay, so we call this reflection. So this one is y equals x squared, and this one is, let's say, y sub 1 equals negative x squared. So they are actually just the same, but every point on x square, every y value on x square is being multiplied by negative 1. So this one is what we call reflection. So y sub 1, which is the one opening downward, is a reflection of, or we can say that in terms of y. So let's erase this one. You can reverse this statement, although it's the same meaning. But okay, so let us say y is, when I say I'm talking about y, I'm talking about this graph. I'm talking about this. Okay, y is being reflected along. So what is the axis of reflection? So we have two axes of reflection, of course. We have a lot of axes of reflection if you're going to go to higher math. But in this case, let us say the y-axis and the x-axis first. So or the line of reflection. So they are being reflected along. The reflection is along the x-axis. This one, this line. So we can say that y is being reflected along the x-axis to obtain y sub 1. Okay? So, ibig sabihin, if we're going to reflect y equals x squared along the x-axis, you'll get y sub 1 equals negative x squared. Okay? Here it's the same. So, here it's the same. This one is y equals x squared plus 3. Okay? This below is just y equals negative x squared plus 3. Okay? So, let us say this is y sub 2 and y sub 3. Let's say that way. So, y sub 2 is being reflected along where? It's not anymore x-axis. Okay? So, what is the equation of this line there? Okay. What is the equation of that? Because the x-axis, you can also say the equation of that is y equals 0. Okay? No, yeah, y equals 0. So, we can also say, aside from saying along the x-axis, we can also say y is being reflected along y equals 0 to obtain y sub 1. So, here we can say, what's the equation of this? If this is y equals 0, what is this then? Okay, that is y is being reflected along y equals positive 3, y equals 3 to obtain y sub 3, which is this one, which is this graph. Okay, so what does it mean? This graph is being reflected along this axis, which is along this line y equals 3 to obtain y sub 3. Let's proceed with the next one. So compare the graphs of the following. Okay. So we have here f of x equals 4x squared and g of x equals negative 4x squared. So of course we have negative 4x squared. G of x is just a reflection of f of x along the x-axis, because the vertex of this is still at 0, 0, 0. So this one, okay, so as you can see, from x squared it becomes 3x squared. Okay, then so there is happening there is a vertical scaling of a factor of 3, and there is reflection. Okay, so meaning after it is being scaled vertically by a factor of 3, it is being reflected along that axis. Okay, so if we're going to do that, it's like this. Okay, so suppose this is x squared, which is this one. So, and this, suppose this is 1, and this is 1. Okay, that will be multiplied by 3. Okay, so this is 1, 1, 2, 3. The next point will become here, and let's say here. Okay, so let's assume that there's no negative yet, so the line becomes like this. Okay, so let us say, okay, so this is scaling by vertically scaling by a factor of 3 first. No reflection happening yet. Okay, so the graph continues there. Okay, so that is from x square. So this is from x square to 3x square. Okay, but after scaling vertically by a factor of 3, this becomes, this blue graph is being reflected, okay, on the same axis, okay, so there's negative. So meaning, instead of positive 3, it becomes negative 3. There. So the final graph, okay, so the final graph is not, I'll erase that one, it's not this one, okay, because this is just the after scaling by 3. So after scaling by 3, it is now being reflected by this axis. So got that? So meaning the final graph is, this is 3. Okay, this is negative 3 there. That's negative 3, and so on, continuous points. Okay, so this is x squared, and this is negative 3x squared. Okay, so how do we do that? Is that we say, that, I'm just gonna change that into another, okay, x squared is being is vertically scaled by a factor of 3 and reflected along the x-axis to obtain what? To obtain what? To obtain r of x. So meaning, x squared is first vertically scaled by a factor of 3. You know that a while ago. Then after that, it is being reflected, okay, along the x-axis. So this is now the graph of 3x squared. This one. Negative 3x squared rather. Okay, so let's continue. So here what we're going to do is to name the graph. So that's after we understand what is it mean by vertical scaling. We understand what does it mean by reflection. Okay, then we were able to compare. So now, so this is, let us say, we'll use this y equals x squared, okay, to name the function, to state the equation of the function of the green, the red and the purple graphs. Okay, so let us do that. So these are all vertically scaled, of course. Okay, so let's try. So here we have, this is 1, this is 1, okay, and this is 3. Okay, so you see that? You see the pattern? So this is scaling from 1 becomes 3. So from 1 it becomes 3. It's times 3. So let's see again. This is 4. This is 4. And it is being scaled up to 12. So what does it mean? The 4 is multiplied by 3. So again, it's like saying that this x squared, the black one, is being scaled by vertically by a factor of 3. So as you can see, from 1 it becomes 3, and from 4 it becomes 12. Okay, it is being vertically scaled by a factor of 3. So what it means that the equation of this one, so let us say that's y sub 2, because we have already y here, that is x squared but being multiplied by 3. Okay, so that's our equation of the function. How about the red one, the red graph? So let's erase first. Erase this one first. Okay. So this is quite so from 1, as you can see, it becomes 8. So it's 1 times 8, 8. So meaning this one is y equals y. Let's say what this is, y sub 3 equals 8x squared. Okay. So how about the purple one? Okay, the purple one. So it's like the purple graph is a reflection. Okay, so a reflection, and scaled, there is a vertical scaling and there is a reflection. So what is that? From 1 it becomes negative 10. So that's negative 10. So meaning this graph is y equals negative 10x squared. Okay, because each point on x squared is being multiplied by negative 10. Okay, so but when you say multiplied by negative 10, it is vertically scaled by a factor of 10, and is now, after scaling by a factor of 10, it is now reflected. Okay, along the axis of reflection. Okay, so we have here, so let's try to use this graph to create another graph. Okay, so again, this one is y equals x squared. So let's say y equals x squared. So let's try to draw the graph of, let us say, number 1. Let's try to say y equals 4x squared. So how does it look like? Okay, so we're going to use this point. Remember, each point will just be multiplied by a factor of 4. Okay, so let us say this is 1. Of course, 0, if you're going to multiply it by 4, it's also 0. Okay, it's going to change that. 1, if we're going to multiply it by 4, it becomes 4. So it's the same here. So look at the symmetry, the importance of the axis of symmetry. Then this one is 4. If we're going to multiply it by 4, it will become 16. So that's it's here. So the same idea here. It's 4, so becomes times 4, it becomes 16, because we're trying to sketch the graph of 4x squared. No, that's wrong. But it shouldn't be here, it should be here. Then the 3, which is 9, it is now being multiplied by 4, it becomes 36, and that is upper there somewhere. So if we're going to sketch the graph, just like that. Okay, then continues there. Sketch the graph, then continues there. That's y equals 4x squared. Okay, so let's say another one. We have y equals 7x squared. Okay, 7x squared. So meaning each point will be multiplied by 7. So 1 times 7 will become 7. So 5, 6, 7. So I'm just gonna change that into another 7. So this one will become 7. 5, 6, no. This is 7 there. That's 7 there. Okay. Then we have, of course, the same origin. Then this 4, this one, that's y equals 4, will be multiplied by 7, and that will become 28. So we say 28, 25, 26, 27, 28, 25, 26, 27, 28, 26, 27, 28. That's here. That's here. And the same with this one. That's here. So meaning the purple one there and there. Okay. So this one is y equals 4x squared, and this one equals y equals 7x squared. So see that? So that's what we call transformation of functions. We are trying to get the equation of the function or the graph of another function using a reference graph, which is our x squared. So that's is effects of a. Okay, so we have here effect of the value of h. Okay, effect of the value of h. So again here, just to name the functions, this one is y equals x squared. This one is meaning here we are trying to change the values of y equals ax minus h squared plus k. This one, this graph, the next graph, this one is y equals, let's say y sub 1 equals x minus 3 square and k is 0. Then the red graph is y equals x minus 5 square, and last graph, I think you know it already, y using the pattern x minus 9 square. So what does it mean? So if we're going to, as you can see from x square, if we're going to increase the value of h, 3, 5, 9, okay, so when h becomes 3, 5, 9, the graph moves to the left. Okay, the graph moves to the left. So that's first our idea that, oh yeah, the graph of x square moves to the to the right, sorry, to the right, moves to the right. But in what specific concept does it move to the right? Okay, so let us try to see that. So what do we know? So let's try to see. Here, as you can see, this is x square. I'll just y equals x square, and let's highlight this y equals y sub 1 equals x minus 5. So this is horizontal shift. Okay, so the graph moves to the right or to the left by certain number of units. Okay, that is what we call horizontal shift. Shifted horizontally. The graph is shifted horizontally. So horizontal shift. So it's since this is horizontal, you say horizontal, that's x-axis, that's x value. So meaning each of the x value on this